Okay, welcome. I'm going to show you how to use this Jupyter notebook that I've created to help your students understand the sampling distribution and central limit theorem. So I've created this and I'm storing it on GitHub. So I'm going to give you this link and you can go to that and get that link. So let me move this. And if you go over here where you can download the raw file, you will download it. It will go into your downloads there. And then I'm going to use Edge because I'm not signed into anything on Edge just to show you that you can do this without any open accounts or anything like that. But if you go to collab.research.google.com, it will open this Collab file or Collab website and click File, Upload Notebook. And then we'll go to Browse. I just did that in my downloads. That was the file. It opens the notebook. I have everything here. Now, in this notebook, I have that you can change these values. It tells you in here what you can change and not. I'm going to make this a little simpler so it'll take a little shorter runtime. You can change the size of your population. These are pennies, nickels, dimes, or quarters. I'm going to do, there's 1,000, so I'm going to do 50 as sample size. 1,000 coins in my population there. And I'm going to do, let's do 2,000 samples instead of 20,000. Well, yeah, that'd be good. Okay. And so now I'm going to go up here where it says file, and I'm going to, we're going to runtime, sorry. Runtime, we're going to run all cells. You would, of course, want to read the instructions and explain to the kids what's going on before you do this, but I want this video to be short. It's imported the libraries from Python. Now it ran the cells. I'm going to go over here and show you what it did. And it reported out here that your 2,000 samples of 50, sample size 50 from your population of coins. The mean value of the simple simulated sampling distribution here is 0.1837, standard deviation 0.0131. And the mean value of that whole population of 1,000 coins is 0.1835, pretty darn close. The standard deviation is 0.0934. And if you use the standard deviation of the population and the square root sample size, you'll see this is a pretty close approximation to the sampling distribution from the central limit there, or the standard deviation of the sampling distribution from the central limit theorem. Also graphs to show you, you can change the population. This is a left skewed population, but you can do it to make a right skew or bimodal or a uniform or however you want this distribution of coins. And they will get to see that the simulated sampling distribution is approximately normal and that it has these characteristics that line up with the formulas you teach them with the central limit theorem. So pretty cool simulation, I think. You can change this, play with it once you have it in here. You can go back, change, and run again. So we'll change this. Let's make it a little bigger here. Let's go 1,000. Make a population of 10,000 coins. And let's make a sample size. Let's not make it too big. Let's go and make it 100. And let's do 2,500 samples. How about that? You can change it to whatever you want. Don't edit the code below this line though, or you will change all of what's happening unless you know what you're doing. Well, maybe we didn't do enough samples there because of population, but you can still see it's approximately normal. You can still see that the mean of the sample distribution is approximately equal to the mean of the population. And we did 100 was our sample size that time. So this is pretty easy to see that the standard deviation of the sample distribution is what we expected it out of this. Might want to change those numbers a little bit to make that graph line up according to the population that you put in there. So if we had 10,000 of those, let's just go ahead and do 10,000 samples. How about that? and run it again. You can also run it with this little arrow here. And a little bit easier to see there, but approximately normal. Again, the numbers are what we expect them to be. So anyway, that's a little thing you can use to show your kids and help them understand the sample distribution. Play with different numbers, play with smaller sample sizes, play with smaller populations, larger populations, and different shaped populations. And they can see the value in the central limit there and what it can do for us with the sample distribution. That's the goal. So thanks.